Hey, Andy here. Got a really interesting opportunity. Now that I've got a fancy flash array here in my house, I want to actually have Portworx being able to run on Kubernetes, to talk to the array and create persistent volumes directly on the array. So I'm not going to use any local storage on the nodes themselves. And really, if we take a look at the why, like that's a pretty good place to start, right? Why are we doing this? If you look right here, I've got a kind of a typical model of all the layers that go into like IT systems. We start with, computer hardware, storage, networking, maybe hypervisors, maybe a Kubernetes layer, then your application layer. If we can actually go and merge some of these layers, let me go ahead and merge that, add the Portworx logo in there, right? If we can merge some of these layers, we're going to get a much more efficient infrastructure. We're going to get economies of scale. So in other words, we're going to be able to scale a lot bigger. Being able to provide volumes outside the size of a traditional VM or even a small bare metal node means we're going to save on hardware, plastic, maintenance, operating systems. We're going to save on a lot of stuff here, especially if we're doing like this whole digital transformation. I'm using air quotes because it's kind of overused, but it's an industry standard term. There's a lot of opportunities here to couple some of these things to scale quickly, efficiently, especially doing more with less heavy well, right? Seems like there's a lot less people in the industry than there was a few years ago. Oh, excuse me. Just getting over the cold or something. Not a big deal. Okay, so what we're going to do in this video is we're going to go ahead and I've got a 3-node cluster running in Harvester. Let's go ahead and refresh this, make sure this is up to date. Yep, cool. There's my 3 nodes. They're running on a little Minisforums box. And I've got an array here, but what's interesting, if we'll go in here to storage, dashboard, I literally have one volume. In fact, I can actually go and delete that volume as a test vol as planned. Let's go ahead and destroy it. So I literally have no volumes, and I can eradicate it so it's really destroyed. So I literally have no volumes, no nothing. Okay. What we're going to do is we're going to configure the array with an API token. We're going to deploy Portworx. We're going to tell Portworx to go talk to it. And then we're going to deploy some apps and kind of see and watch as the Portworx nodes, the Portworx persistent volume claims actually get created on the array. Again, really trying to show you how we can merge some of these lines. And oh, by the way, now that I'm thinking about it, because I got this tab open, and this is a great advertisement for Portworx, but really kind of think about, right, that Kubernetes layer, any application. Now we can do, with Portworx, we can do, disk duplication, compression, backups. I got another video on using Portworx for backing up an entire app and then redeploying it to a new cluster. We could absolutely do this with, both Portworx talking to different arrays. There's a lot of different ways we can kind of Lego block this into a really good solution. But this is kind of cool, right? Any storage, any Kubernetes, right? Which is good. I like Rancher RKE2 because I just came from there. This absolutely works. This absolutely works on like kubeadm, OpenShift, any of the kubes out there. In fact, it may be fun to try. With something like Spectro or some of the others. But let's just stick with what I know right now, right? Okay. This instruction will be included in the show notes as usual. In fact, I'll actually have a gist with all my notes to kind of show you the steps I took. There's some prerequisites here. I've already gone and installed them, but I'll go ahead and double check. Yeah, I've already gone and installed them. So what I've done right now is I've already set up the 3 nodes, so the run on all the nodes. I've set up the multipath because that's required. I've set up the udev rules and installed some necessary packages. Then I've started multipath D. Then I went and on the server, I deployed Rancher RKE2. Not Stig, no special configs, nothing crazy. And then I went on the nodes and go ahead and connected them as worker nodes. So we can go here in my cluster and we can see I've got a 3-node cluster. Port 1, 2, and 3. Okay. First thing we need to do, once we've got the cluster up and running, we need to go and configure. We don't have secure boot because we're in a virtual machines, right? So what we can do now is we need to go to the cluster, we need to create a user, and we need to create an API token for that user. So let me go to the cluster, I'll go to settings, I'll go to users and policies, and under users, I'm going to go and create a user, and we'll call it nope, not per auto-filled, YouTube demo. And we're going to make them a storage admin. Password, I'll use my standard. If you know what it is, cool. If not, it's PA22WRD. Password does not match. There you go, that should work. Okay, cool. So I've created a user. Nope, don't need to save that. Now we're going to do is go ahead and create an API token, and we're going to call it 365 days, doesn't really matter, and create. So there's my token. Okay, what I'm going to do is I'm going to copy that, and we're going to effectively create a JSON file. And I just need to paste that in here, so I'll paste that in. And this, again, will be in the show notes. That's all we need to do on the array. The other thing, well, let me phrase that. That's all we should need to do. The other thing we may want to do is go to the connector and really look at the management. So notice we've got management here at 2010. But I've also got, just to kind of point out, I've also got a management virtual interface at 192.168.1.11. And for those that are curious, I'm actually SSH'd into the array. I always forget off the top of my head. Pure. Hold on. You can tell I'm still relatively new with my Pure commands. Yeah, Pure Network eth list, and I just grep for true. So let's go ahead and just hit that, and we can see these are all the network interfaces that are active right now. By the way, I want to point something out that I'm only running basically a data cable from one of the controllers. Amazon delayed the delivery of my SFP Plus to RJ45. But what we can see though is that's a file virtual interface. And then I have this management interface, which is F0. I have a second management interface. So both controllers have a management interface, but I do not have that physical. There we go. There. I've only got C0 F5. And then we've got that virtual, which goes to iSCSI. Even though it says management, it actually is used for iSCSI as well, which is cool. So what we can do, oh, by the way, that is management. Let me correct that. That is the management for both C1 F0 and C0 F0. The reason why we need it for our docs is because, remember, it's doing the management side. And if you've ever done an iSCSI initiator, oh, I forgot to run that. Let me run that. If you've ever used iSCSI initiator, then you'll know that, like, we need unique names, and that's what we're going to check real quick. And I had the other tabs open, but I jumped ahead. So let me cat that. All I have to do is make sure that it's a different iSCSI name. So bear with me. But yeah, so when you and you'll see in a second, when you do an iSCSI initiator, it'll say, oh, here are all the volumes, which will include the IPs of the physical NICs. So let's go back here and get the name. Like I said, we just got to make sure they're different. So it can't be BE, right? FF, FE, and 7. Okay, cool. So we have our 3 names. And then we can do our iSCSI. Let's see if this actually has it. Boop, boop. Yep, iSCSI discovery. And what I'm expecting to see is 192.168.1.11. I'm expecting to see 1 back. Oh, that's cool. Oh, because that's the management port. We need the actual port, which was, what did we say it was? .7, right? So we'll go to .7, and there we go. So there's the actual interface for iSCSI. If I had that second controller plugged in, you would actually get 2 back. So that's why you don't necessarily need a virtual interface for iSCSI, right? You actually get multipath. So it knows how to get to each one of them independently. Okay, I hope that's clear. If not, just comment, call me an idiot, and then I'll reply and hopefully do a better video explaining it. Okay, so all we've done so far, we've got a 3-node Kubernetes cluster. We've validated the iSCSI initiator names. We installed the iSCSI packages so we can talk iSCSI. I've gone to the array, and I've created a user and then have an API token. Because what Portworx, by the way, what Portworx is going to do is it's going to talk over the management port to the array and say, hey, I need a volume. It'll get the iSCSI volume, and then it'll connect it to the pod as needed, which is great. It'll actually also use the array for some of its management, its key value database for Portworx itself. So that's pretty cool. We'll see those volumes come up. So now we get to deploy Portworx. I have a video on this, and I can give you the TLDR. Effectively, what you do is, let's go back, scroll down. Effectively, what we're going to do for deploying Portworx is we're going to go and we're going to install the operator and then generate a storage cluster. And the trick is the storage cluster basically saying, no, we want to use FlashArray iSCSI. Okay, we're getting ahead of ourselves real quick. Let's go ahead and create the namespace. CTO get NS. We can see we've got the namespace now. I need to create a file with not only the management endpoint, but also that API token. All right, so we're going to go and create the file, and we're going to create a secret within that namespace for the file. Okay, so now we've got the secret created. We can go ahead and install the operator, and we'll give that a sec. For some reason, my bandwidth's been a little slow off this node, so we'll give it a shake, stick, and a jump. Cool. And kubectl. We can go containers creating. We'll sort that down to Portworx. We can see it's creating. Yeah, we're gonna check that box. I think for some reason it's running slow off the network. Although let's see the dashboard real quick. I should buy more hardware. I think that's the answer. I think that's always the answer. Let's go back here and see if it's up and running. Still creating, so it's obviously pulling pods. While it's doing that, we can take a look real quick at the spec for the storage cluster. So KVDB, so that's the key value database for Portworx. The storage is set to 30, I believe it's 32 gigs. We can see the current version, image pull always. Actually, I like changing this, if not present. That's a little more friendly for air gaps. I don't want to save it. A little more friendly for air gaps. I do turn, the CSI obviously needs to be enabled. Monitoring and telemetry I turn to false because obviously we're playing. We don't necessarily need that. And we've got Prometheus Grafana turned on. Yeah, I'll leave it on. That's not a big deal. Although for this demonstration, I'm going to set it to false. False. And we're running. Cool. The operator's running. So let's go ahead and apply that spec and see what we get. So one cool thing, because it's a CRD, we can go kubectl get CRD name and check all namespaces. We can see that it's right there, cluster ID status. It's initializing. We'll watch that for a second. And actually, if you want, we can do kubectl get pod. Okay, so good. Container creating. That's what I like to see. Watch this. Dash and say 5. Whoop. Okay, so this, like I said, this may take a minute or two for it to come up and running. Actually, we should already start to see file systems volumes. Okay, once the pods are created, we'll start to see that. What I'm going to do is I'm going to go ahead and pause the video right now, only because it's going to take, well, okay, so we got running. We got the extensions. We might not have to pause this. This might be quicker than when I was playing earlier. I was running in a multipath D issue that I had to go sort out, but not a big deal. And we'll refresh this page. Okay. What we actually will start seeing is some of these volumes getting automatically created. 104, still downloading. And here, let's go crazy. Oh, wide, so we can see where they are distributed on the nodes. And notice like the EXTs are evenly distributed. Portworx does require 3 nodes. I was trying to do this the other day with one, and we're obviously running into issues. Oh, there we go. There's our first volume. Hopefully you guys saw that. And if we want, we can go ahead and take a look at the volume itself. Now we will start a connected host group. It's already in a protected auto group, which is nice. So if we wanted to do data protection, if we had multiple arrays in an active cluster, that would be a really kind of nice way to manage that in terms of a policy. Cool. Running 404. I like it. We should start to see more of those coming up. Cool. This is much quicker than I was doing it earlier today, or I should say yesterday, which is cool. And there we go. There's our 3 drives. Awesome. So it's well on its way up. Cool. I don't have to pause this. I love it. kubectl get storage class, and this will show you all the different storage classes. Now, one thing I like to do really kind of helps for developers is create at least a generic default storage class. That way the developers don't have to be very specific in what they're requesting. And you can put some sane constraints around it. Case in point, bandwidth, allow for expansion, backend equals true, things like that. So what I'm going to do is I'm just going to go ahead and create I'm basically going to create a new storage class to make it simple, to add some of those provisions to it. We can go ahead and get SC. What I've also done is I've made that the default. Okay, this gives me again the opportunity to make my developers' lives easier. And again, kind of thinking about this stack rate, about efficiency, about making some of these decisions just simple and easy, just so it'll work. So let's go ahead and refresh this. Okay, we still have our 3. Let's go ahead and get pod just for giggles. And we can see everything's up and running. Awesome. Now, let's go ahead and actually test it. Did I have the doc? Yeah, I'll include this too. There's a doc here on configuring and testing with direct access, and you can go in this. Again, this is where that storage class comes in, but I added that annotation for default. But we can go, and let's go ahead and just make read write once. So we can go ahead and make a PVC, put it in the default namespace. Cat EOF. You can tell I've typed this a few times. F. Cool. Now that's applied. If we go back here to the storage, we've instantly got at 20 gig. Okay. And if you noticed, we were requesting 20 gig PVC-A, and there's our one PVC at 20 gigs. To have a little more fun with this, what I'm going to do is I'm going to go ahead and I've got an app here that I've modified. This is, if you've seen my videos before, this is my generic Flask app. And I'm going to leave this kind of open so we can see. We can hit apply, and it's going to basically create a Flask front end, a Redis back end, a PVC, and ingress. And while that's coming up, what I need to do is I need to create, so you can see the app. Well, we don't really care about the app. Get ingress-a. We can see it's flask.rfed.io. Pod-n Flask. Learn to spell. Put get in there so the container's creating. We can get the PVC. We can see that second PVC at 1 gig is already created for Redis. We can go here and we can already see. So notice that was F60 and F60. So there's our pod. There's our PVC for it. We can go to hosts. We can see that we've already got our 3 iSCSI connections from the host, and there are our volumes. We can also go to the dashboard and start looking at performance and what's talking. So that's kind of cool. Again, we can go back to storage. We can go to volumes. We can see our volume. And let's just see if our pod's up and running. Yep. Container's still creating. And while we're waiting, let me go ahead and exit out of this. I don't really need that node anymore. I'm going to go ahead and create just so you can keep me honest. What I'm going to do is I'm going to go ahead and add an IP address for one of the boxes. So let's go port 1 and call it flask.rfed.io. We'll save that. And I always like flushing the DNS on a Mac when I do it. Container's still creating. Man, for some reason I think I'm rate limited by Docker. Might have to pay them for my IP or something. But if we go flask.rfed, okay, it's not up yet. I wonder if the front end will freak out. Yeah, it's just load advanced. This is unsafe. I don't have my keys signed attached to it. Yeah, so Redis isn't up yet. I've got the Flask front end automatically give the debug, which I'm fine with. Wow, it's still pulling down Redis. And I'm using Valkey, which is really small. I wonder if that's an issue. STL. Unable to attach. Failed to process the volume. Oh, okay. I see what's going on. This is my fault. And you can keep me honest. Let me flip over to the file. This is the file I use. So there's this new volume in the persistent volume mode block. And because I was trying to do read write many, but it's read write once. So what if I just did this? Actually, if I just go PVC. So kube ctl get pvc-a. So I'm going to edit it. And I believe that's called Redis. I'm just going to take that line out. So that volume mode for block is for read write many. Oh, it's not liking it. Let me do this. I'm going to use the big sledgehammer. Force flask. Well, that's happening. This was me trying to play, right? That's what I get. Let me go ahead and commit that. No block. Let me go back to my notes. Now it's completely deleted, so it's kind of cool. So we'll see nothing here. We'll go back to the storage. The volume's already deleted. Go ahead and apply that. And then just validate that it's... Oh, it's still there. Dang it. Yeah, it didn't like that. Okay, I must have gotten a different version. Or didn't update the version. Let's see. So we're on. I really want to fix this. I think it's kind of important. Let me go and make sure that the version's been pushed to GitHub. That's a good idea. Let's start there. So we can go... Where is it? Ingress. I swear I pushed it. You gotta love when Chrome caches. Let's do this. Let's cheat it on the command line. Pew. See, it's commented out there. Well, it looks like it's mounted. Bound. I bet you it's the same thing. Which is my fault, but it should be relatively easy to fix. The volume Redis has volume mode block, but it is specified in volume mounts. So that's rewrite once. Yeah, it's not in the pods, the deployment spec. Think about this for a second. What's the easiest way to do this? Actually, we'll do this. We'll nuke. I don't know these. The volume Redis data. It should, because it's commented out now. So if I change the name, this is going to cause problems. I'm going to leave it as is. No, I do want that commented. Okay. Well, let's delete it for a second. And let's go into the array. Let's try something real quick. Let's go into the array. And we should see it destroyed in a second. And it should be this last one, this 1 gig one. What I'm going to do is I'm going to make sure that it's actually destroyed. Refresh the page. Yep, it's fully destroyed. Go here. Even though... There you go. Now... Let's try deploying it one more time. I don't have volume, so you can see I don't have volume block. I don't have it anywhere else in the file. I only have it once in the file. And by the way, the volume block was for read, write, and many. Oh, let's try that. You know what? Read, write once. Many. Hit save. Because you know what? I feel like breaking things. More block. And just for giggles. So this apparently was a new annotation, for the spec. Let me find volume mode. Yep, here we go. Volume mode file system. Persistent volume deletion protection finalizer. There was one that described the different types of modes. Here we go, volume mode, right? So it's file system or block. To use the volume as a raw device or is mounted into the pods into a directory. And how do I have it set up? Do I have it mounted as a directory? I do. I thought I had this working. Maybe I need to just leave it as file system. Well, file system is the default, so let's go ahead and move it back. Well, let's deploy it as is. Why not, right? And we'll go ahead and let's do the curl. Let's see what it looks like on the curl. Okay, so we're waiting for it to update. That's the only downside when when you do kind of rapid deployment, rapid development. Sometimes you got to wait for GitHub to get their act together. Well, here's what I can do. We'll cheat it. Cat EOF. Cool. There's the volume. Creating. I probably broke it again, but that's fine. That's fine. So let's try it one more time. And we'll do delete. And while that's deleting, I'm going to uncomment that one. And I'm going to make this read write once. So now we shouldn't have any of no block. Will I push that? No block. Block. Because I'm crazy on my commits. Okay, that's done. By the way, you should see the rapid. I mean, this is pretty cool that I'm able to deploy and play and redeploy and play and redeploy, and it's creating those volumes on the fly, which is actually pretty cool. So cat, type it in. Deployed. Learn to spell. Creating. Let's describe the pod. Cool. Okay, it's pulled. Oh, it's pulling the image right now, which is good. Oh, I'll probably move to a different node. Wah, wah. There we go. And it's running. Yay! I did it! And there we go. There's my Flask app. And again, there's our... So, just to kind of point out that the hit counter is in Redis, which is writing to that volume. which is pretty cool. And then we could, you know, I don't have the backup tools installed for Portworx, but you could definitely add the backup tooling. It's part of Portworx Enterprise. And then take advantage of that, like backup to S3. I could run MinIO talking to iSCSI. In another video, I showed being able to mount the iSCSI volume directly to the VM itself. So that could be another path to data. Gives you a lot of options. And for me, I like the simplicity of being able to use one enterprise storage device, right? Big, loud, noisy box for not just VMs, not just potentially hypervisor, but then also up into the Kubernetes and kind of stateful storage for the applications. My next video, I'm going to actually probably purchase another small box to work on Harvester. So being able to store hypervisor data and application data and, you know, end user data, right? All on the same kind of device, which is really cool. And by the way, don't have any file systems. I've showed another video where I've mounted and copied files over to it, which is pretty cool. So being able to leverage, like I said, a big enterprise box at scale for multiple purposes and leverage the same disk duplication, backup strategies, protection, right? I don't know. If I had two of these, I could actually start connecting them in an active sync, active cluster, active disaster recovery. I've also got snapshotting, which is cool. So these are snapshots from some of the volumes I created the other day. You can see the dates on them. So really cool to be able to take advantage of all of that enterprise goodness. I hope this is informative. I hope this helps. Kind of see the power of Portworx talking to a FlashArray. And if you've got any questions, feel free to comment as usual. Like, share, subscribe. Have a good day.